Hello students, welcome. Previously, Form 4, Topic 3, Lesson 1, we are dealing with the introduction side of the chemistry of reaction rates and reversible reactions. So today, Lesson 2, we are going to do factors affecting the rate of reaction. So I told factors that increase the rate of reaction do so by 1. Increasing the number of effective collisions or increasing the number of successful collision. Number 2, lowering the activation energy, since a reaction with high activation energy it is low at ordinary conditions. So these factors are, that means the factors that affect the rate of a chemical reaction include 1. Concentration of reactants, and concentration will be used when the reactants are in solution form. Then number 2, we're having temperature. Number 3, we have surface area or the size of the particle. Number 4, we have catalyst. Number 5, we have light. And number 6, we have pressure. And we are going to use pressure in the reactants which are gaseous form. Okay, number 1. The first factor is concentration of the reactants. So we are saying increase in concentration of one of the reactants leads to an increase in the rate of the reaction. Reason, we are saying this is due to the increase in the amount or in the number of reacting particles, hence increase in the number of successive collisions by unit time, thereby increasing the rate of the reaction. So that is the reason why when you increase the concentration of one of the reactants leads to an increase in the rate of the reaction. So next we are going to go to comparing the rate of reaction at different concentrations. So we are saying here at higher concentration the reaction is faster. When the concentration is high, that means the reaction is faster, while at low concentration the reaction is slow. So when you have your concentration as low, that means the rate of the reaction will be also low. Reason, this is because at high concentration there is a high amount of reacting particles, or there is a high number of reacting particles, hence high number of successive collisions by unit time, while at low concentration there is less amount of reacting particles, hence less number of successive collision by unit time. Okay, next we are going to go to examples. Example 1, we are told the graph below represents the volume of gas collected against time when dilute sulfuric acid is reacted with the zinc granules or solid zinc. So we are having here the graph. This is a graph. So we have the x-axis time, which is measured in minutes, and on the y-axis we have volume in centimeter cube. That means the volume of the hydrogen gas produced in centimeter cube. First of all, before we go to the questions, let's just try to know the scales that they have used on the x-axis and the scale that they have used on the y-axis, scale in the x-axis. So in the x-axis we have here 0 and we have here 1. That means 1 minute. So 1 centimeter square in the x-axis they have used half a minute. Half a minute. That's the scale on the x-axis. Or we can say 1 centimeter square they have represented 30 seconds. So what about on the y-axis? On the y-axis, here we have 0 and here we have 100. That means here is 50. So what they have done is they have used 1 centimeter square to represent 50 centimeter cube of hydrogen gas. That's our scale. You have to know that. Okay, next we are going to go to part A of the question. We are told determine the rate of reaction between the first and the third minutes. So we are supposed to look for the rate, okay, of the reaction between the first and the third minute. So to do this question, we are supposed to go to the third minute first of all. This is the third minute, and we are going to see where it is cutting the curve. It is here. Okay, so we want to know the volume of hydrogen when the time is 3 minutes. So it is here. So here we have 200, and obviously here is 250. So each small box will be representing 10 centimeter squared, centimeter cube. So that means if it is 250 here, this is 260. So 270 is up there, so it is in between. So that means that is 265. So we can have here and say when x and y, if we have as a coordinate of x and y, the x will be 3 minutes here and the y will be 265 centimeter cube. Okay, we're done with that, the third minute. We go to the first minute again. So in the first minute, we have here. So let's just check now the volume at that first minute. So we go and count. It is from here all the way to there. So each small box, we said it is 10, 10. So here is obviously 50. So we have here 60, we have 70, we have 80, then we have 90. So that means if we put here x and y as our coordinates, x is the time, that means we have 1, comma, then the y coordinate there will be 90 centimeter cube. So let's have our formula for rate. If we want to get rate, we have to use the formula change in y over change in x. When we're talking about change in y, that means us having y2 minus y1 divided by x2 minus x1. Okay, thereafter, let's just try to put our values. So we can have here to be x2, y2. That means this one will be x1, then y1. Let's substitute now. Let's substitute. To substitute, we are going to have our y2 rate will be equal to y2 here will be 265 minus our y1 is here 90 centimeter cube divided by what's our x2? X2 is 3 minutes minus what about x1? X1 is here, it's 1 minute. So this will be equal to, we are going to have 175 on the change of y divided by 2 on the side of the change of x. Here we are going to get 87.5. So what will be the unit for this rate? So it will be centimeter cube per minute, because the volume here was in centimeter cube, per minute, because the time was measured in minutes. This will be our answer. Okay, we go part B of the question. We are told when the reaction stops. So that means we can see the curve here. We are having this point where it is flattened, where it became horizontal. That means we check this time, because we are told when is time. So this is 5, this is 4, and this is 5. In between them, so it is 4.5 minutes. That will be our answer. 4.5 minutes. That will be when the reaction stops. Okay, next we are told give a possible reason for the reaction to stop. We can have 2 reasons there. Check in the question. We are told the graph below represents the volume of gas collected against the time when dilute sulfuric acid is reacted with zinc granules. A reaction will be complete if one or all the reactants are consumed. So that means if dilute sulfuric acid is used up, that means the reaction stops. That means there is no more formation of hydrogen gas. So if zinc granules are consumed, all of them, or are used up, that means the reaction too stops. Because we are told if one of the reactants is consumed or is fully consumed, the reaction stops like that. So our answer, we are having 2 possible reasons there. The first reason will be zinc granules was used up. Or we can have point 2, even we can say dilute sulfuric acid. Dilute sulfuric acid or sulfuric acid was used up. We said if one of the reactant is used up, that means the reaction will be in completion. So next we are going to go to the third question. Next, we are going to go to the second question. In the second question, we are told 2 experiments were carried out as follows, and the volume of hydrogen gas evolved, measured at intervals of 10 seconds for 100 seconds. Romeo 1, the first experiment, that means 8 centimeter of magnesium ribbon was added to 1 molar hydrochloric acid. Then in the second experiment, we are having 8 centimeter of magnesium ribbon was added to 0.5 molar hydrochloric acid. So here, the 2 experiments, the change was only in concentration. That means the mass of magnesium was constant or the same. So we are told graphs of volume of hydrogen evolved against time was plotted. Here we are having the one for graph A, and here we are having that graph B. Here we have the volume of hydrogen, centimeter cube, and here we have the time in seconds. So let us see the questions. And we are told here, which of the graph was obtained for reaction Romeo 1 above? Let's check reaction Romeo 1. In reaction Romeo 1, we are having 8 centimeter of magnesium ribbon, which was added to 1 molar hydrochloric acid. The other one, we are having 8 centimeter of magnesium ribbon, but it was added in 0.5 molar hydrochloric acid. So that means the first experiment was having higher concentration, which will lead to a higher rate of reaction. That means we're having B, curve B. So the answer will be curve B or graph B, and the reason is the acid had higher concentration. So that means the one that's having a higher concentration will be the one that's having a higher rate of reaction. So but B, we are told explain the general shape of the graph. Here we are saying the rate of reaction is initially high because of high concentration of the reactants, but decrease steadily as the concentration also decreases. Remember in our previous example we said as a reaction takes place, the concentration of the reactants decreases as that of the product increases. We are going to go to the third question. That was question number 2. In question number 3, we are told the sketch below was obtained when 2 grams of magnesium was reacted with excess of 2 molar hydrochloric acid. The volume of hydrogen evolved was then plotted against time as shown below. So we're having the graph like that. This is time in seconds. Here we have the volume of hydrogen in centimeter cube. So we're having here part A, B, and C. So we are told the first question, on the same axis, plot the graph that will be obtained if 1 molar hydrochloric acid was used instead of 2 molar hydrochloric acid. And we are supposed to explain. So we are supposed to sketch first of all on the diagram, and we are going to explain down there. Okay, so we were having this curve is for 2 molar hydrochloric acid. So this curve is for 2 molar hydrochloric acid with 2 grams of magnesium ribbon. So we are told to sketch on the same axis another curve that has now 1 molar hydrochloric acid instead of 2 molar hydrochloric acid with the same mass of magnesium. So how are we going to know? We are going to know 2 molar is in a higher concentration when compared to 1 mole. That means the rate of the reaction will be steeper. That means here the gradient will be steeper. So we're going to have something like that, and we're supposed to label this as it is 1 mole hydrochloric acid when we use 1 mole of hydrochloric acid. So the answer is graph should be less steeper, showing lower reaction rates since hydrochloric acid is less concentrated. Because now we're using 1 molar, but initially we were using 2 molar. And this one is the one that was having 2 mole HCl, hydrochloric acid. So we go to part B of the question. We are told explain the significance of the flat portion BC of the curve. This BC is here when the reaction comes into completion or complete. So we are saying graph flattens out at BC, showing that all the magnesium has been used up. Hence, no reaction is taking place, and there is therefore no evolution of hydrogen gas. The volume of the gas therefore remains constant. That's the end of our lesson.